I was really excited when I heard that Ryan was going to be talking tonight because I follow him on Twitter. And if you guys were looking at his LinkedIn bio, you'd find out that he's been a lead engineer at quite a few companies, including Tesla and Facebook most recently. But both in and out of that work, he does something that I find super inspiring, which is he has a clear focus on data visualization and live editing with fast feedback loops, trying to either change data or look at data in more ways than just ASCII. And not only that, but with a mindset towards making that ability democratized across multiple skill levels. So I'm super excited that Ryan's presenting tonight.
Woo! Nice. Thanks. Can you guys hear me?
Yep, we can hear you.
Awesome. Let me just share real quick. Cool. Can you see that too?
Yep.
Awesome. So yeah, I think that's a great way to present it too, because in terms of like, being an ETL guy and a data viz guy for so long, I used to tell people in classes, like for dashboarding, like all this fancy shit aside, all you're trying to do is communicate information to another human being, right? And I think that bleeds into a lot of like different parts of our space, even to ourselves, right? Writing a program, you want to know what's going on over here, over there. You don't want to like do it blind, right? So essentially, I'm going to go through a whole lot of stuff here. It's essentially 3 applications. I'm going to go really fast because the one at the end is the one I kind of want it all to coalesce in. But it's this idea that if you take a lot of time thinking about a space, thinking about a problem set, what can you do with that, right? And these 3 apps is kind of like my journey of like, hey, let's try everything, to then be like, okay, well, what actually works and like, what can I go with, right? So some people may have seen the Data Rabbit stuff before, so apologies for that, but it's fun. So yeah, the idea, familiar with like Brett Victor, that kind of work, being able to kind of like extend your senses into the program, back and forth, input and output, that kind of thing. Seeing, in quotes here, more context, like what are the things adjacent, what I'm working on. And, as Adam said, interactive feedback loops. I want to do a thing. I want to see what happens. Then I can change my behavior and maybe get something else out of it, right? So Data Rabbit. So Data Rabbit is kind of my attempt to, I fell in love with Clojure, and I was like, being like this ETL guy, an old school ETL guy, I'm obsessed with that kind of like data flow systems, right? Flow-based programming is you have black boxes that have a process sending data or a signal to another box that does something else. And that's kind of really a great fit for Clojure and like functional programming as a whole, right? So, all right, let's see here. Let's drag in a block and drag in another block. So we can see here that, let me just zoom in a bit. If you can't see this, it's not a big deal because the code's not super important. Let me hide this panel. We have a Clojure script block, evaluating in the bootstrap here, hiding Clojure script and then the version. Have a server block. You can see it's running on the built-in nREPL. Clojure, 1.10.3. And over here I have this editor, right, where I can change the code and reevaluate. I have the output here. I have different things for the output. I can switch the layout of this window here. I just kind of want to make it an all-in-one way to like, I'm going to jump in, I'm going to start building something and seeing things, right? We can go over here to see. So this is the out auto. See, it makes it all nice and a larger font. I could say out text and just see the raw text, giving different ways to see things. I can drag out of this. So we can see we're running this, we're getting a string, right? That is the output. It's what we're rendering. If I drag out of this block, I get the string. And now instead of this block being code, it's a reference to this thing. And see, I hover over, it says, this is where this value comes from over here. Same thing down here. This idea that we're running code and flowing values that can be interpreted by that block or not. Okay, cool. So we're flowing stuff. Awesome. You can see this yellow outline and the yellow line, and you can see it says string here. Now, I'm not one of those super zealous like static type guys. I like the dynamicity of Clojure and not having to worry about that. But when you're looking at something from like a 10,000 foot view, it becomes kind of important to see what things are without having to zoom in and look at them. So I kind of have this idea of like pseudo data types, right? Then we have strings. I have something called a row set, which is literally just a vector of uniform maps, something you might see, you know, with SQL output, you know, just kind of a grid, nothing fancy there, just different ways to display it as text, as a grid, as this visual map, which is kind of like a nested version. Floats, integers. This is a vector. You see the same map box rendering. Also, render things. Since this is all web-based, here's some hiccup of some, you know, Buffy the Vampire Slayer JPEG, and it says, oh, this thing's renderable, so I'm going to render it. I can look at it as data and it's itself, right? But as a render object, you know, that's what it is. So this gets kind of interesting when we come over to, here's a nested map. I don't know if you guys can see that, but so here's a nested map. Pretty simple. Got some vectors, maps, some embedded stuff. And that's all well and good. It's kind of easier to understand this way at the, you know, cost of some screen real estate. But we have this whole, like, you know, tangible interface here. We can take it a little farther. So let's say I have this map and I want to see just this vector, right? And of this vector, I just want to see this key. So now we're creating get ins and gets, and we're pulling the map apart. And it's still this map, right? If I look at this map being defined and go to the output block, it's just a reference. It's a get in this incoming thing in MM4, and then out to the next block, which would be over here. Same thing, you know, whatever's coming in, do a get in to in and then TT. So that's kind of the flow. And again, I'm going really fast, but some of this stuff is important for what's coming up. Okay, awesome. We got data types, we've got some hiccup. We have like basically interconnected REPLs that are executing stuff. Awesome. Here's more rendering. So we have a recom list. Let me just reformat that here. We have a recom list that's drawing some boxes that have an on-click event that populates an atom. You know, recom is a kind of like an easy way to do like what is it called? The anyways, I just use it as primitives for lots of things because it's a lot more terse than using hiccup divs, right? So anyways, I have buttons, click on the buttons, it generates the atom, changes the atom value. As we can see, I have atoms here. I can say, let me see all the atoms. And then they change as I click. Or let me see just this atom, change as I click. Like this whole idea of, as I write code, I have viewports into what's actually happening in the code, right? So generally, blocks output whatever the output is, but this is rendering a UI, so there is no real output. So if I say, hey, this atom is going to be my downstream output, then I can say, okay, if I drag this box out, I get, you know, 7 or whatever it is. Hide this. And that's just the value of that atom flowing to the next block, right? In addition to that, if anyone has ever used Light Table, they have a cool way of evaluating things. And I have that here too. Like I can evaluate any section of this code if I want to see what it's doing in the greater, you know, whole. Like if I highlight this range 12 and right click, it'll show me, oh, that's 0 through 11. That's cool. If I go in and this commented out code here where it's doing a for loop, you know, I can see it renders as a vector, you know, with the labels, cool. I can also use that same function to change stuff that the UI understands. Like for example, like this is a hex color, right? So I know how hex colors work. So boom, change your hex color. Very kind of Brett Victory. Like I just want to see what feels right, you know, for what I'm trying to make. Same thing for, you know, pixels and integers and floats and these things that are easy to scrub and more of a pain to have to go back and hunt and pack and hunt and pack. Even something like this, range 12. Well, it's just an arity to range, right? I can create as many things as I want. And, you know, you can scale this up as you go into stuff. So that's really cool. Again, we have this kind of canvas we can do stuff on. All right, well, let's do some stuff that's actually like more interesting, right? So what do we have here? I have of course, I mentioned Brett Victor, so I have to do the tree. His tree is a lot sexier than mine, but you kind of get the gist here. You know, modify, you know, this random variable, and we can see the tree change. And you know, as if anyone's seen that his awesome demo where he does this in JavaScript, like a JavaScript like book layout. Pretty cool. Again, so you have the tree. Or if we want to go totally crazy, all this is hello, let's canvas tree atoms. This is the same tree, except instead of just being code, it has atoms hooked up to it to change the values, just as an example, right, of data flowing. And as you can see, they're kind of grayed out because these aren't explicitly dragged in here. These are just making references because of the atoms that are used, right? Slider value 8, slider value 3, 4. Just kind of example of like, this is the kind of reactive kind of thing that I was going for in this. And all of it is, all of it is just closure. There's no real magic macros. There's none of that stuff. Because if you want something to be like a learning tool, and then I wrap it in a bunch of wrapper functions, well, what are you learning? You're learning my wrapper function, right? Which, that's not super great for anybody. I mean, no offense to things that do that, but I just like, you want to learn stuff that you can take outside of the tool and use somewhere else. So one last thing on Rabbit. If you want to interrupt me, go for it. But it's like, okay, so let's do something quasi real world, right? Like I've never worked for a company and they're like, draw me an SVG tree. I wish, right? So go in here and let's say, what else we have? We have some stuff I've saved. Here is, I'm in the wrong, hold on, I'm in the wrong flow. Okay, sweet. So I mentioned pseudo data types, right? That a row set, a vector of independent, a vector of uniform maps is kind of the thing that we use a lot. So I, created a data type for it. What about other stuff? So we have here, here's a JDBC connection. It's to this SQLite database I have with a bunch of Bigfoot sightings on it that I may or may not have scraped off some Bigfoot site. But it knows that it's JDBC. See, it's got this like pumpkin-y color. And since it knows it's JDBC, it can simply do the thing like, go and get what's in this data set, regardless of what it is, right? If it's ClickHouse or MySQL, in this case, it's SQLite. And you can see we have some tables here rendered out on the canvas. Well, again, much like the map pooling, if we're doing canvassy things, then let's do canvassy things, right? Drag out Bigfoot sightings, drag out locations, drag out whatever UFO sightings. It's saying, it's interpreting my action and being like, okay, well, looks like he wants to do a select all. So here you go. Here's your Bigfoot stuff. And if I look at the code, again, I would use HoneySQL, but again, we're trying to learn stuff here. So it's like, this is a little bit messy, but like the point is we're taking your action, we're generating code for you. We're not necessarily hiding it. And you can go in and change this whatever you want, but this is what's generated like off the bat here. But again, much like JDBC, since it knows this is a SQL query, I can also have a SQL UI to change this and then kind of like build code for you with magic UI, but then you can fork it to do other things or mess with it to understand what it does. So here I'm going to say, all right, we're going to do count. And anyone who's done use like Tableau or whatever, that means it's a very like common like interface for SQL. Okay, we have count and class, the group by, and class is like some Bigfoot sighting thing. Cool. So we have that, and we've just changed our data set. Awesome. But I want to see that better. So what can we do here? Well, clicking on these rows basically shows the UI what the map looks like, right? So I have this button here called clicked row. I can go into clicked row and say, hey, make like count the y-axis, make class the x-axis, and then make me a bar, and then I drag the bar out next to it. So now I kind of have this, I have this like Nevo chart, right? That is drawing what's there. It's just taking what the input is. See, I hover and it shows the box here and what its output is. And then as I click on these bars, you see it turned pink. It's generating a map from an on-click event. And since it's an output event, I can see that data over here as the downstream flow. And then I can come over here and say, hey, this is like, I want this, I want this data map. And, I want this key. And then as I change things, like it changes. And you can imagine this looping back into another part of the application or doing some kind of like filtering or a whole dashboard like this. This is that same data set. And again, there's a lot going on here, but it's kind of an idea. So we have all these different things that are generated that are coming together to be composed together in a single view. And it's going to be cut off a little bit because of resolution, but this is essentially, if I bring up the editor, and again, sorry for the crampedness, this composer view is literally just showing all the different pieces on the canvas that came together to make it, right? So I created all these little pieces and I composed them together in essentially a dashboard. So if I turn this off and then I interact with this, you know, it changes because these things are all linked together in the canvas, right? So if I were to change this, it's going to be super small and impossible to see, but just to get an idea of like, if I select another state, all this will change and then visualization will come upstream to this, right? Which is pretty cool. I mean, you wouldn't ship this to production because there's obviously latency doing all this stuff. And some blocks are slower than others, but it's kind of a really interesting way to tackle the same kind of problem that I've done 10 different times, right? Like it's not a notebook, it's not doing things piecemeal, but it's kind of interesting. So before I move on from Data Rabbit real quick, I mentioned Clojure server connections before, and excuse me, it can also connect to nRepls that run, you know, server side. And the cool thing about that is that I'm mixing front-end Clojure script with back-end Clojure that doesn't need to know about it. So right here we have an encanter block that's connected to another REPL I've running on my machine, just generating some sample viz like you would see on their README. And these are just Clojure script sliders. And as I change the slider, obviously I get a new, you know, it's a little bit of latency since got to pitch it to the nREPL and then get the response back as a JPEG, but just kind of a cool thing, right? Like it's completely divorced from this, but it's being orchestrated by the front end, right? This is some ML data set using their Titanic examples. And I bring this up because we can see here's our REPL output. So this is what's actually being printed to the console. And over here is actual data that's coming out. And I say actual data because if I go to here and say out, again, sorry, I'm kind of cramped. And I'm gonna drag this out. This is the data from the data set, right? So this is not necessarily the REPL console output, but a separate output that I can then use and say, hey, what if I wanted to take this and make a graph out of this that is now on the front end? So we've bridged that gap. We've bridged that divide both ways, right? In and out. So anyways, a very, very kind of interesting way to do stuff. So I mentioned this kitchen sink stuff because back to the kind of like vision, right? I want to try a whole bunch of things and see what actually makes sense. So I did this for a while. It was very cool. And then I kind of got burned out of it and I wanted to try to apply those to another niche, so to speak. And you know, the ChatGPT and LLMs and the whole thing's been hot for a little while. This is kind of a tangent, but I was like, well, what would the same interface look like if it wasn't so like developer based and was more of just like getting shit done in this kind of interesting space with the same kind of like interaction primitives, right? So sort of this. So this is Rabbit Remix, which is, you know, the side forking of Rabbit for, you know, AI stuff. And let's see here, we can do, let's bring out a chat window. And another thing that came out really interesting here is that voice is actually way more interesting than I thought it was. So if we go here and I say, hopefully this works with a zoom up, say, hey, how's it going? And then it comes back, obviously it's an AI, it doesn't know how anything's going. So I'm like, okay, that's kind of cool. We can like do some interesting things with that. Created a speaking block, a speaking block, and then I drag out the data. So since we're still in this flow-based world, right, I drag the data out into the speaking block.
Hello, I'm an AI, so I don't have feelings, but I'm here to help you with any questions or assistance you may need. How can I assist you today?
So kind of goofy, but kind of interesting at the same time, right? Like, no, I'm good. Just testing if you still work.
I'm glad to hear that. Yes, I'm here and ready to assist you whenever you need. Feel free to reach out if you have any questions or need any help.
Yes, Rich is very helpful. But anyways, so kind of like this interesting world where I'm like mixing that paradigm with some more end user focused stuff. I have HTTP calls, which interestingly enough are just those drag pull maps, right? The request is a map and the output is a map. So this is hitting an Owen Wilson API and it's getting these values and I can do what I want with those values, send them to other blocks. There is eval. I don't know why it didn't eval. There we go. Same kind of thing, you know, hi from Clojure script. Except the interesting thing I did here is that, like, you know, we're Clojure people, right? So code is data, data is code. I was like, well, that's kind of interesting if I just make it render as code. So I could say, here is this. I'm going to drag my response into my eval window, and we can now see from the code it added as a let binding with all the movie names. And I can edit this and say, all right, well, hi from Clojure script, and let's just put in, you know, count in, what was it called? Count, the binding is in 1. And then I have, oh yeah, should be a space there. But you kind of get, like, trying to, like, you know, link things together. The last thing that's interesting about this is that while GPT-4 has gotten kind of weird lately, initially I had this whole system as like an agent canvas, right? So this is a super prompt on GPT-4.
Oh, sorry.
Yeah, you go for it.
It's having a problem.
What's that?
Can you hear us?
Yeah, can you hear me?
Okay. Yeah. Sorry, our system went on the fritz for a couple seconds. It seems to be working now, though.
Okay, cool. For a second, I thought you were gonna be like, I haven't heard anything in like 5 minutes. All right, awesome. Yeah, so this is kind of like an agent block. And like I said, so GPT-4 has been getting kind of weird lately. So these demos used to be a lot fancier. So this is a super prompt. It knows how to, it's super prompted to know how to interact with the canvas. Oh, and I also told it to act like Buffy the Vampire Slayer. So if it's super cringy, like, apologies in advance. But what's cool about that is that if you teach it to interact with the canvas, you can kind of give it some agency, right? And this was the big part of this experiment. So if I go to here and I say, open up a command block and tell me what version of Python I'm running. And it spawned a console, did Python version, which came back with nothing. And then sorry about that. I thought it would be cute to have this, I thought it would be cute to have the speaking block say I'm alive or yell when I open them. And yeah, that gets kind of old. But anyways, as you can see, I said, tell me what kind of version of Python I have. And it ran Python. It looped back its own result that said not found. And then it tried Python 3. And as you can see, it says here, oh, it looks like Python is not installed, kind of thing.
Oh, it looks like Python isn't installed or accessible in its current path. Let's try checking for Python 3 specifically.
So you can see it's running these kind of meta commands that it only knows how to do because I kind of preset it up here with all the things that it knows how to do. And it's kind of interesting. And I didn't mean to spend so much time on this part of the talk, but it is super. It's so glitchy because you never know if you're going to get like good answers or total like trash. But I mean, to be able to go like, hey, write me a Python script that gets the date of the next full moon, please. And again, it's trying to like figure out if this kind of flow paradigm can work for user tools, right? And especially user tools that can do interesting things. And then, oh, it was supposed to spawn a Python block and it didn't work. So this is the thing. The novelty with ChatGPT is that it doesn't always do what it's supposed to do, which makes demos like this hard. But anyways, this was kind of the tangent I went down with this kind of tool. And then I took a step back and I said, well, okay, this is super cool. Like there's some interesting shit here, right? You know, I kitchen synced it with Data Rabbit. I went a little more narrow with this. I was like, well, if I was going to use this in real life, it's kind of tough, right? Because the problem that these tools both have is that they live in the browser. There's no real way to do them headlessly, right? So if I can't really like run a cron job to run this, it has to be in the browser and have to do all kinds of like weird shit. And it's like, okay, well, what would I want? So if I'm writing an application, maybe the flow won't be the whole application. Maybe it's just like a section of it. So I was like, well, what I need is this same kind of utility in something that I can package up as a library that you can use as a piece of your app that can be usable without all the fanfare if you don't want it, right? So I came up with this thing called Flowmaps, which is essentially flow-based programming with constructs to make it kind of like Data Rabbit, but on the back end, but to also have a fancy front end for debugging. But the front end is completely optional. So let's do a little demo there. I'm going to start a new flow. So since Rabbit is essentially like a REPL client, I'm just going to use Rabbit to talk to the library. So I'm going to bring in a server block. What I'm going to do here is connect to the REPL I have that's running my library, which is available on Clojars. So I have a REPL running that just basically includes a couple of namespaces in the library. So I'm going to use this to connect to that library. And as you can see, it's, you know, Clojure 1.11 instead of 1.10 like I was. Okay, sweet. So let's see here. Let us make this smaller. And now I'm going to cut and paste some stuff real quick. Cool, we're connected to the right REPL. So I'm going to define a flow. So flow is, I wanted it to be real Clojure code, right? I didn't want to be doing like strings and stuff. So this is a map. Components, they have names, and they either have a static value or a function, right? Could be an anonymous function. It could be a function you have in some other namespace. Doesn't matter. It's a real Clojure function. It's not like some thing. And then we have connections, which if you're familiar with Airflow or that kind of thing, it's literally just saying, do this, you know, then that, trying to keep it as simple as possible. So we have this, you know, we have this flow one object. Cool. Oh, yeah, my bad. We have this thing. So now we can kind of do something with it. So this is what it looks like. So I'm going to run the flow command and say, we're going to run flow one, and we're going to give it the ID simple math. And nothing's going to return because it's async. So I'm going to ask for the results with results. Somehow. Okay, cool. So let's see here. What are the results? And we can see for every block it executed, what the output was, ending in 27. And I ran it twice. So, you know, there's the both runs, but has the same value. So it looks the same. Get rid of this. Oh. All right. There you go, a little more. Okay, so that's cool, but not super exciting, right? It basically, it's almost like a threading function at this point. So, okay, well, let's add in some of that observability, right? So let's run it again, but this time, oh yeah, it keeps running. I'm going to start the web debugger. So I'm going to say start. Cool. Oh, did we get an error? Oh, no stuff. Web, is it called fweb? Sweet. Yeah, starting web UI. That's doing things live is always fun. Okay, cool. So it started the web UI, which should be available here. 8,000. Cool. Nothing there. Hasn't done anything because those flows that I ran before, it wasn't running, so it didn't capture them. It just ran as fast as possible. So now I'm going to run it again. We're going to comment out this. And we're going to run that same flow again. We can see here some output, shows all the steps that run. Oh, by the way, I didn't mention, what this is doing is this is creating core async channels and linking them together with functions. So I went with super well-known primitives, nothing crazy, nothing super hacky. So let's go back to our view. All right, as we can see, Simple Math 3 showed up of its steps. And if I click on the view, I can see the flow we just ran, right? Starts off with 10, added something, it subtracts, and then it adds 10, and then it makes it a string to 27. Cool. And I can see here as I hover, these are different steps. All the channels that were open, the core async channels, and all the functions that were run and everything together. But what's awesome about this is that since I'm running this, oh yeah, and a run log, right, to like what it actually was. Since I'm controlling the execution of this, I can also now take it from, we went spatial, right, with the canvas, and now I can take it multi-layered and see time, right? So if I scrub through time, I can see how this executed. And it doesn't mean a whole lot with this simple example, but it can get very cool when you're doing complex stuff. And then not only that, I mentioned here like Marble Madness method of interacting. What I can also do is I can pick any channel in this flow, since as you can see the little fire symbol, these channels are all still alive. So anything I do to them is going to just make the whole thing react. So this 10, you know, I could change that to, you know, 110. It's going to run again, create a new segment here, right? So now we're at, you know, 227, which I can rewind back to the old values, or I can click here and say, go back to that old segment, and I can see the different pieces of time that this executed, which is pretty cool. So let's go back and do something a little fancier. We'll do a flow. It's a little more complicated. Let's see here. So, oh, also, yeah. So this flow function runs async. You can have it output when it's done to another channel or an atom. So if this is just a piece for your application, you can just wait for whatever comes out the other end, and that'll be more interesting in a second here. So let me make another flow. We're going to call this one flow 2. And we'll run flow 2, and we'll just call it 2. And since the web is still running, and you can see here, it's going to show you all the channels that it opened. And if I go back to the UI and hit flows, we should see, there you go, 2. So the flow is called 2, and it's the first run of it. So if I go to this is a little more interesting because we can see here that unlike a simple threading macro, we have multiple inputs to the same function, right? So this 10 and 20 is 30, add 10 to be 40. And this over here, you know, is adding together this vector. It's completely divorced from this one, but they exist in the same flow because that was just, you know, convenient for whatever it is you're building here. Same thing, I can scrub through time. I can make changes here. I could open this channel and looky here. So here's a copy paste. I probably can't read that. Sorry. It's basically an async put to this exact channel that's running in my REPL, and I can dump a value there. Or over here, I can dump a value via the UI and send 123, essentially overriding and shortcutting this connection, right? So it doesn't need this anymore. It already exists. And as we can see, they're grayed out because in this current run I just did, those were the only blocks that actually were impacted. The rest of the blocks didn't do anything. Their channels like sat unused. So that is pretty interesting. I need to stop saying that because that's not really a great presentation skill. But let's run a loop. All right, back to Rabbit. We're going to comment this out, so we don't want to run that again. I'm not going to give it a name. It's just going to pick a random name for me. Looping net and what is it called? Flowmaps, simple namespaces. Hold on a second. I think it's called simple examples. It's just a pre-existing flow. There you go. Let me just copy and paste it here. Cool. And that should be running. Let's go back here, open the flows, and we can see, oh, look at all these waffle boxes. So this is a loop, which again is something that in a threading macro would be onerous. So this is kind of cool. So what it's doing is it's doing something similar before. It's taking these 2 ports, as you will, which wait for this to run, going to this loop, and then it's looping around until it hits a conditional output, and then going through here. So we can see it looped 23 times before it hit the conditional, which in this case, I think is like, it has to be over 800 or something. But I can come here and I can see this is where the conditional kicked off at the end, and I can go back in time and see each loop as it ran. And oh, by the way, notice there's a Vega Lite drawing here. each view not only can have its own output, but can have its own viewer. So you want to write a small viewer function for a block? Yeah. How's that for a print line? I can scrub through this and see time going up. Very cool. Again, this is only because I'm debugging it and I'm running it in the UI. If this was just run without that, it would just give me the answer, which in this case is whatever this is, you know, done with a string. And then it has the same kind of stuff as the other two applications where I'm visualizing maps. You can see the map different ways. You can just show the text, you know, has all that, like, you know, I want to see things from every other, you know, every single angle. Kind of interesting. The last thing I'll say on this is that actually the viewer thing is kind of takes some explaining, right? So I have, ooh, where is it? Actually, here, let's do this. Let's do, did I do flow 2 in the last one? Sorry. Oh yeah, so I have, so what I can do here is we'll do flow 2 and I'll say, you know, view, again, apologies if you can't read this, you know, function, and I can just say, you know, recom, child, string, X, whatever. And basically the view function is going to run that after it gets the results, right? So function takes the input from where whatever its predecessors are, it runs it. The results get sent to view and or speak, which is like the print line here, and then shows it. So if I were to run this again, so what is this? This is flow 2. We'll go down here, we'll uncomment this, we'll get rid of the name because I don't want to overwrite it. All right, we'll run that. So flow 2 should have a new 7, and it's this guy here.
Just a heads up, we have about 10 minutes left in the event, so if you want to leave time for questions and answers.
Yes.
Yeah.
So I'll do one more thing, and then we'll be doing questions.
Sounds
Cool.
great.
So if I do to, what did I give the view to? Just look what block it was. It was simple plus 10. So if I go to simple plus 10, I should have a value here for view, and view is, oh, because I screwed up the recom. But you kind of get it, right? So it'll run the data and be a view, and that could be anything. You know, it could be you know, Vega Lite, it could be Hiccup, it could be whatever, it could be actual speaking, right? I use the same voice 11 labs code to be like, hey, if I'm in the other side of the house and I'm running an ETL job, I might want to have it, you know, alert me when it's done. So we can do that also.
Hey, genius, I figured out your brain buster of a math problem. It's 40.
All right, so that's a whole lot of stuff. But basically, I'll just wrap up by saying, like, it's that kind of thing, right? Like, let's explore all the edges of an idea. And even if they don't all work, maybe down the line, you can say, hey, maybe these other things do work because I went kind of into it to see what it is, right? Oh, and the last thing I'll say is that this put, all these channels and all these blocks are also REST endpoints, if that's enabled. So I can literally have another application that says, hey, insert a value into this channel and then pick it up when it hits this channel. And I can have another function that literally runs this flow without knowing anything about the flow. It's just picking up async channels, which is actually, I'm trying to build a whole application on that. So that'll be cool. But anyways, yeah, I've done a whole lot of talking and showing stuff. So I would love, if you have any questions, I'm gonna stop sharing for a minute so I can see y'all. All right. Thank you for your patience with that. But I thought it was cool to like go the whole way and say, this is how I got to here.
Yeah.
Hope I didn't bore you too much.
Yeah, I have a question. First of all, thank you for showing that off. There's some really cool stuff there. I'm very intrigued by the timeline you were showing off.
Mhm.
So, you know, I assume left to right is the actual time. What's the other axis represent? Because I noticed they're all kind of drifting up.
Yeah. Shit, I shouldn't have stopped sharing. Let me go back real quick. All right, you can see it again?
Yes.
All right. So what we have here is basically in this top part, these are the channels, and when the channels get the value, when they dump the value off. And down here is the functions and when they execute. I'm adding like a millisecond to these so they actually render, because this happens like immediately, you know. But for things that run longer, like ETL jobs, it's a little more nuanced. So let me close this. If I'm just looking at channels, right, I just see the channels, and you can even see the value generally. So value 20, value 30, and then this is the done block, value 40, that's for up here. And that's kind of time, time left to right and scrubbing through it. If I have them both, it's just functions. I mean, and in most applications, they're kind of very similar, you know, but I thought it was cool to be like, all right, maybe if I have my function is like effing up somewhere, it might be good to see, all right, well, it was delivered the right value here, you know? So that's kind of what the idea was there. There's also this run log, which is the same thing, except very literal, like linear, you know, like this channel grabbed this value, it took 0 milliseconds, and then we went here. And the same thing, like up to down, left to right, you know, this is the execution. I probably should have picked the more complicated flow. But yeah, that's kind of what I'm trying to show, like points in time. I don't know if that answers the question, but that's kind of and the time segment thing is kind of interesting too, because this loops, right? It looped 23 times. If I go to where the loop starts and I insert like a low value, I should restart the loop again. And this is our old run, right? And this is our new run. And this time it took 32. If this is doing a random integer counting, so it's different, you know, times the loops. Same thing. So now because I pushed that value, I created all these side effects in order to get out to, they're not really side effects. It's just flowing data, but still to get this final value. So yeah, I just wanted to be able to see the execution, because with core async, it's dope, but it can be so like daunting, like what is actually happening, you know? And I just kind of wanted to do, like, not to steal too much of Brett Victor stuff, but like, you know, I wanted to make core async flows without a blindfold on, right? Does that make sense?
Yeah, thank you so much.
Anything else? I know I covered a whole lot of stuff. I had a question about cloud collaboration. So I noticed that the was it the app remix URL looks like it's public, and a lot of the other stuff you've been doing is localhost. If you're going to have multiple people collaborate on a Data Rabbit dashboard, would you tend to encourage the cloud-based workflow?
Well, this is kind of an interesting example, because you can see I'm using a totally public URL with a gist, right, that had my saved stuff in. But it's talking to localhost. So basically, I'm going to push it out as a Docker image, but I have a jar that runs locally. And this app, all it does basically says, hey, is the thing running at localhost port whatever that responds to X, right? And if it fails or doesn't give it what it wants, it won't show the shell, you know? It's kind of like a weird thing that this was kind of meant to be a Docker thing, but I was like, oh, I'll just use like the hosted version. So as far as that stuff goes, I don't know. I mean, there's a lot of multiplayer stuff that could be done here. In fact, in Rabbit, I had this whole, I didn't show it because it's like super uncooked. I had this whole like ChatGPT thing in Rabbit too for like changing code and going back and forth. But this chat window could be another person because it uses the same, like I'm using, you know, everyone talks to the server, right? All the clients have where's the thing? Has a name, you know, here's the random name for this node, this client. So I guess to answer your question, I don't know, right? Because I haven't done enough of that. But Remix, you know, reads off public gists. This is running in your application, so this has its own. I changed the window. So you could totally collaborate on this by just sharing the gist, just like adding to them and then republishing. You know, I have this whole thing here for, you know, new gist, saves a gist, kind of thing. Because I just wanted to show URLs on Twitter that people could like open up my stuff that I made, right? Like there should be an example here. Back before GPT-4 got all weird, I had this whole video where I went back and forth with the AI for it to create like a good fizz buzz. And it's crazy all the iterations it went through to try to figure that out. But like all these blocks were all generated by ChatGPT. And I was just kind of like talking to it and like egging it on. So like, there's definitely some cool iteration stuff here, but I guess to answer your question, like, I'm not sure. That's a long way to say I'm not sure, but sorry.
Yeah, no problem. That was interesting. Thank you. Oh yes,
Hey.
there's one other question for you in chat. If you can see that from Christian.
Yeah, can you hear me?
Yeah, we can
Yes,
hear you.
yes.
Okay, cool. Yeah, this is super cool. I've heard of this actually a month ago from somebody working at OpenAI. He told me about Data Rabbit, and I hadn't had a look yet. Like, I think I need to
Nice.
take a closer look. I've interacted with quite a bit of like functional programmers and category theorists, and I'm not saying this is necessarily of value, but could you see that there is a benefit of basically declaring boundary types, so that if you plug things together or find basically compatible like flows, that you could automatically find like things that even match in that type. Like I can imagine if you would do this on a larger scale and you would have a lot of these flows, you might want to reuse like subflows and be able to quickly pick them up and make suggestions about them and stuff like that. And then it could help basically to know what fits and what doesn't. I'm not sure where this fits like your flow, but like your personal flow.
Yeah, and that's kind of the, oh, sorry. That's kind of the basic idea, is because if you look at something like the first demo with Data Rabbit, is that you're creating blocks that can be reused. And this is kind of that, except in code, right? So the next, I had this whole thing with spec that I wrote, but I didn't end up using it because it just got too complicated. But the idea was, hey, this is my output or return. What things do I have that are compatible with this, right? And it could be a whole library. I'm going to try to make a batteries included version of this. There's a whole bunch of functions that you can basically use. And I think the next iteration of something like this is literally being like, okay, I'm dragging in pieces together, right? That are then generating this map that I use in the back end, but debug in the front end. So it's kind of like the Data Rabbit idea, but not all in on like burning your Chrome down. You know what I mean?
Right.
But yeah, that's totally some place I want to get to. And on that note, if we have a library of functions that have spec inputs and outputs that the system can understand what needs to go in and out, it's not crazy to think that you explain that to an LLM and it says, hey, build me a flow that does X, Y, Z. And I've already done a little bit of that, but it's a lot harder without it knowing the boundaries. It has to make some assumptions, which, like I said, the latest GPT-4 is not great at these long-winded assumptions currently. But 100%, yes, that's definitely the next step. I just didn't do it here because I was focused on, hey, I want to make something that's actually useful in the back end without getting too, I mean, Rabbit is awesome, right? But the amount of stuff that I put into this application, it's dope. But at some point you scope creep yourself like to death, right? And I was trying not to do that here, but
Yeah, it makes sense. I'm just also like, I have one more question actually. Like, maybe that's, I'm not sure whether it's helpful or not, but I will ask it anyway. So, like what kind of data model or database would you like to have ideally if you basically distribute these flows? Like one thing that I was thinking about is like, would it be helpful, for instance, the stuff that I've been working on is like, if I could pass pointers to database snapshots between machines, and you can basically refer to the same value, like if you have like a distributed flow, as you said, like over REST interfaces and so on. Like where do you think are unnecessary complexity problems if you would actually try to scale this and do this, let's say, between multiple people and systems, like this kind of programming model?
Yeah, I mean, that's definitely also, I have a function here to use like durable atoms, like duratom, right, which just stores them as files, which isn't really super great, but it kind of makes it persistent between runs. But as you said, I mean, since I'm storing all the information, like it would make sense to have something like, and I will look at like Data Hike for that. Like, I just haven't done a whole lot of like data log stuff. I'm a SQL guy, right? So like, I'm like, oh my God. But yeah, 100%, because when you want to be sharing those values, and think of it this way, I have REST endpoints where I say where client X puts a value on channel Y and wants to pick it up on channel Z, right? I want to make sure that I give that same value back to client, you know what I mean? The client, whoever it is. And there's this whole kind of like thing there that goes beyond the channels to kind of, because the channels are great, but they're kind of ephemeral, right? It's gone. I want to make sure if you pick it up tomorrow, you're still getting the right value. And that means I need to have a whole persistent database system, at least scope to the app you're working in, not necessarily like like Airflow, like the world, right? But on that level. But yeah, that's definitely something I'm thinking about next as well. And your
Okay,
talk was actually
cool.
really interesting on that front. So I may have to ping you later on that, but totally.
What is the channel that you like? Is there a Slack channel basically to hang out in? Like just join on Clojure? Or?
No, I mean there's I don't go on Clojure and Slack that much. I mean, you can send me a DM on Twitter, or email me. Oh, yeah, should have had that up there. Yeah, I mean, ping me on any of these things, email me, whatever. Like all I'm focusing on right now is this kind of stuff. Like I'm not doing full-time work at the moment. So it's kind of what I'm trying to figure out. But yeah, ping me in all these places. I'll mention, I know I've already gone over, but I'll mention there's a thing here called Canvas QL, which is basically applying these same ideas to a SQL Vega world. If you know like what that might look like, because that's the world I came up in, right? Is all like Oracle, SQL Server, all that shit. Like I think in SQL still, it's like a disease. Anyways.
Well, it's just in some way like okay, if I would have to sell data log to you, I would say it can be much more concise because you have first class logic variables and the binding is implicit. It's just
and it's data structures, not ugly ass strings that are change between platforms. 100%.
Right. Yeah, super cool. I will play around with this. Also, I should also like.
That's wild that you said that. That's wild that you said someone from OpenAI told you about it. That's crazy.
Yeah, it was kind of yeah. I think yes, I think you made some waves. Super cool.
All right, if that's all the questions, then we will conclude the event. Let's get one final round of applause for all of our speakers.